Hello everyone, welcome to our tracing talk. My name is Ilya Kislenko. I'm software engineer at Kasten.
And I'm Ashlie Martinez. I'm a first-year PhD student at the University of Washington, and last year I was an intern at Kasten.
As you can see, I'm presenting on behalf of Julio Lopez, who is not with us, who is not here today. He is the proud father of the newborn baby and spending time with his family. But I was helping to develop this talk and also worked on the demo app, so we should be good. In this talk, we will describe our journey, how we were adding tracing into our existing Kubernetes application. And let's do it. At Kasten, we're developing Kubernetes native application called K10. This application helps to manage stateful applications in Kubernetes. And it's microservices. As you know, microservices are complex and really hard to debug. So our journey with the tracing started when few of our tests starting to be flaky, and we were getting some random timeouts, which we wasn't able to explain. So we spent a lot of time looking for the logs and metrics, but nothing was there. We thought that 13 close to that microservices would be easy to debug with the only metrics and logging, but we were proven wrong. To debug microservices, you probably need the whole trifecta. You need logging, you need metrics, and you need tracing. So that's how we decided that we need it. And the thing in our case was that we already had an application which was working. And we needed tracing yesterday, and we wanted it really quickly, and we didn't actually want to disrupt our development process or rewrite the whole application to start supporting tracing. So that's how it was our journey, and we will describe in this talk what we did, how it worked, and what's the result. Let's look at the Kubernetes ecosystem and what's the actually Kubernetes native application looks like. If you look at the GitHub, you will see that most of the Kubernetes native applications following microservices pattern. Most of them written in Go. Also, most of them using API first approach, and also most of them using code generations because it saves a lot of time and it's just easy to do things. To make this talk a little bit harder for us, but a little bit more interesting for you, we developed a sample app called image application, and we were trying to make it in the cloud native fashion, which means it has two backend microservices. Image catalog, which is metadata store. It talks to the database and fetches all the information about images like paths, where it lives, and some metadata. Also, it has image store, or the store service, which saves images data on the local hard drive. Both microservices written in Go, and we're using Swagger to generate our HTTP JSON APIs, services, and the client. If you're curious, here's the GitHub link. App is open source, it's in Helm, there's some bash script which helps you generate everything, and it should just work. So, I believe all the demos and presentations are supposed to be entertaining, so let's start with the demo first, and then we'll talk about it. And also, I don't believe in the demo gods, that's why we'll be using video. Let's open our application and see some beautiful pictures. It's Fipi, if you're not familiar. It was created by Matt and Bailey, and I heard the rumors there's the second part of coming. We can see the pictures, we can see the slides, everything fine, everything works. But as the developers, we keep changing our application. And in the following update, we're going to introduce really cool new feature called random slowdowns on the fetch image from the store, which means every time when you're reading, it might be super slow or super fast. So we're upgrading our application via Helm, because Helm is amazing. If you're not using it, do it. Upgrade done. Let's go and check how our application works. We hit refresh, and nothing. As any other normal user, you hit refresh again. Then you're getting scrolling, you're waving your mouse, you're getting frustrated, nothing is loading or loading super slow. So I would say for the really simple picture gallery, it shouldn't take more than a few seconds to actually load everything. In our case, it takes longer than that. So as the developer, you have to go and actually debug it. As the creator of this beautiful app, trust me, you will not find anything in logs or metrics, but just some random timeouts. But good for us, we actually have tracing in our app. So let's go to the tracing UI. and see what it does. This is Jaeger, and as you can see, it has information about our two services, metadata and store. Also, it shows traces. What they are, I will describe a little bit later, but trust me, they are good. You can see some durations, some of the traces slow, some of them faster. Obviously, we want to find which are slowness and where it is. To do that, let's find all the traces slower than 10 seconds. Here's one of them. As you can see, this is the GET request to metadata, and it takes 14 seconds, which is super long. Here's our trace. As you can see, trace has pretty much chain of actions through our application. The first one, we're getting incoming GET requests into the store to get image with some UID for our image, which triggers internal function to actually fetch image, which also slow. The next will be find image, which is relatively fast. It's only like tenths of a second, which means our database behaves properly and it works fine. The next request, you can see outgoing and incoming request into the store from the metadata, and the final one is actually read data from the local store, which is still 30 seconds. Probably we should go to the store metadata and see what's happening over there. Another great feature about tracing, and Jaeger in particular, that it can give you diagram of dependencies for your microservices. As you can see, here's our two microservices, metadata and store. And that's how they work. Metadata pretty much calling the store for the images. So, it was our app, even that it's pretty simple, only two microservices, but without tracing to find that slowness, you probably would spend a few hours, because you don't need to compare logs from the different microservices, find the same timestamps, and if, for example, your microservice is written in two different languages, it would be even more complicated. Metrics will not, if you're using only metrics, also will not help. It will show you, hey, some requests hitting a threshold on your timeout, but not much info. With the tracing, it was relatively quickly, because we just went through the whole chain of actions and we'll see what's happening. So, what is distributing tracing on the high level? You'll be surprised, but it's also application. It's sometimes one application, sometimes two applications working together. What they do, they automatically aggregate traces which your app sends to them, collect them, and doing some correlations. Also, they highlight the execution path of the request. They help to pinpoint failures and where the slowness occur. And this is not a replacement for logging or metrics, but it's super complementary to them. So, what you already heard a few times, I mentioned trace, span, what they are. Relatively simple. Think about the trace as the chain of actions. When you do something to the application, for example, you fetch an image, it starts the chain. The first one, as you remember, it was the call to the metadata, then the call to the database, then the call further. So pretty much it's like all the actions which are happening through your application for particular action. What the spans? Spans actually the small steps or the functions. So as you can see on the diagram, application sends traces with the multiple spans to the Jaeger. Here's a developer. That was me sometimes at like 1 a.m. trying to understand why it's slow, why it's not working. But most of the time I just go to the tracing UI, look at the things and fix them. What we're using and why we're using it. Since we're developing cloud-native application, we decided to go to the CNCF and find what we can use from them to add tracing into our application. We like two things. Thing number one, OpenTracing, which is actually standard with the SDKs and the pretty much every popular language like Go, Java, C#, and those SDKs helping you to instrument how you send traces into the distributed tracing collector. And the second one is the Jaeger, which is the visualization application, which can read data from the databases, allows you to do searches, can do comparison, as you can see, helps you to do create the diagram. But there's not only OpenTracing and Jaeger in this world, there's other offers if you don't like these two. For example, there's Zipkin, there's Google Open Census, some cloud providers also offering you some tracing technologies, like, for example, AWS X-Ray. At this point, I want to hand our presentation to Ashlie, to the person who actually added support into our application.
All right. Thanks, Ilya. So as we just saw in our demo, we got a nice overview of OpenTracing and Jaeger and kind of how they work. But for now, let's dig into more details onto the OpenTracing Go SDK itself. As you noticed in Ilya's demo, each trace is made up of several different spans, which are nested inside of each other to show the execution path of the program. OpenTracing accomplishes this nesting by leveraging Go's context object, which it expects to be propagated throughout the entire program. What this means for you as a developer is that if your program doesn't currently propagate Go's context object, you'll have to do a little bit of extra work if you want nicely nested spans like we've been showing you. Finally, OpenTracing allows developers to add extra information in the form of what they call tags. This information can include things like the status code from an HTTP request, or other stuff like request IDs. This information helps give developers a good idea of what the state of the system was when the span was collected, as well as helping them associate specific spans with the output of other tools like logs. So with that information in mind, let's move on to actually adding tracing to our demo application. We'll begin by looking at our architecture diagram and deciding that we want to add tracing for incoming requests to our image catalog and our image store services. If we open up our image catalog service, we can see that it's actually made up of three main parts. The middleware, which is Go's way of adding custom features to the incoming HTTP stack, application code, which the developer actually writes and does interesting things, and an HTTP client that helps push out requests to other microservices in the application, or perhaps outside services like databases or cloud providers. So, given that we want to add tracing for incoming requests, we decide that we should look at the middleware area here. For this, we've created our own little custom middleware, which leverages OpenTracing's library calls to begin and end a span automatically for us. Now, I said that OpenTracing actually uses contexts to store information about spans, but on this slide, you see no context object whatsoever. Under the hood, OpenTracing is actually extracting a context from the incoming request, starting a span with it, adding the modified context back into the HTTP request, and then passing it down to the next middleware in the stack. So, when we compile and deploy this modified application to our cluster, we can see that we only get one lonely little trace, which is not really what we were hoping for. From our architecture diagram, we can clearly see that our image catalog calls our image store service, but the span that we just collected does not reflect this. In order to try and fix that situation, we decide that perhaps we should add tracing to the outgoing requests from our image catalog service. Once again, if we look at the zoomed-in view of our image catalog, it seems that perhaps instrumenting the HTTP client for outgoing requests would be the best place to start for adding tracing. We decided that creating a custom HTTP transport, which is part of the Go stack for adding custom functionality to outgoing requests, would probably be the best solution. Here you can see the actual code that we've used. We first pull the context out of the outgoing request and have OpenTracing begin a span using it. Next, we place the modified context back into the request and have OpenTracing inject some special headers that it uses into the actual request to be sent out. Once we send the request out and get a response back, we extract the HTTP status code from it and place it in a tag so that developers can look at it in Jaeger later. As a reminder, the first time we added tracing to our application, we only got this one span. However, when we compile and deploy our newly modified code, we get three lovely spans clearly showing the connection between our image catalog service and the store service that it communicates with. However, we know this is still not the complete story, because both of our services talk to some sort of store. The image catalog talks to a database, and the image store talks to the local hard drive to retrieve image data. So we feel perhaps we should instrument these calls as well. And we can see that we actually have to instrument developer code in this case, instead of some of the more generic code that Go uses to handle HTTP requests. But before we get to the code, perhaps we should take a step back and ask ourselves, since we're communicating with external services, can we always just use the trick from our previous part of adding tracing, where we create a custom HTTP client? But it turns out that not really. It really depends on which API you use to communicate with other services, because Go has a wide variety of APIs in use. For example, we found that the Kates API doesn't take context objects, which means that even if you do try and use the same trick from part 2, your application will not create nicely nested spans like we've been showing. Furthermore, MongoDB, with the API that we're using, doesn't actually take Go's context objects, so there's no way you could use our little trick from the last part. However, all hope is not lost. For example, the official AWS and GCP Go APIs take both custom HTTP clients and Go's context objects. So indeed, using our trick from the last part will allow you to add tracing to those services. Well, add tracing to the calls to those services. You won't get insights about the internals of what happens in those services. So, with that, let's now move on to the code that we added to trace calls to our MongoDB database. We decided that the best way to add tracing is to add the 3 highlighted lines on this slide. The first 2 begin a span from the context that is passed in, and then finish that span when the function returns. The final line in the set just adds extra information to the span so that the developer has a better idea of what was happening. Once we compile and deploy this to our cluster, we get a lovely view of all of the different spans that correspond to the actions occurring in our application. The first 3 correspond to actions taken by the image catalog service, and the final 2 correspond to actions taken by our store service. So, I know that was kind of a lot of information in a short amount of time, so let's do a brief recap of just adding tracing to our system. We saw 3 different ways to add tracing, and when those ways might be good to use. For incoming requests, we decided that using OpenTracing middleware functionality is probably the best choice. On the other hand, if you have outgoing HTTP requests, you should think about creating a custom HTTP transport which begins and ends spans for you. And finally, if you're instrumenting other parts of the application, you may want to check out the APIs to see if you can use other tricks from the previous 2 for incoming and outgoing requests, or you may have to manually add calls to begin and end spans. Okay, so just a brief recap of everything that we covered so far today. We talked about using OpenTracing's Go SDK to add instrumentation to microservices. We also saw how to instrument external services with OpenTracing, and these external services include databases, the Kates API, and some cloud provider calls. Earlier in the talk, Ilya talked about installing Jaeger with a Helm chart, and he showed us a lovely demo where he used Jaeger to analyze and dig into some of the traces. And now I'm going to hand it back to Ilya to finish off the talk.
So, we just saw that tracing actually helps debugging and understand where might be error or slowness occur. But I believe some of you probably still not convinced that we should use tracing, so let's try to talk to and read your minds. So, the first thing, my login is amazing. I don't need tracing. I can search through the logs, compare logs, timestamps, just amazing. Probably. But we thought the same, and we learned the hard way that probably it's better to use tracing, if it's possible. If not, and you're relying only on the logs and metrics, it's up to you, but trust me, it's a little bit hard. Because logs giving you point in time for your application, when the trace is actually giving you small tiny storyline, what's happening to your application, or what was happening to some actions or the request in your application. So even if you're only relying on login, I would recommend at least you try tracing. I'm getting SMS from nagers. First of all, I hope if you're using Kubernetes, you're not using nagers, and you're using something more modern as the monitoring technologies. But even if you're relying only on the metrics and you don't want to add tracing into your application, and you think you're good, adding tracing will give you ability to do more request scoped metrics. Like for example, you will get less amount of false alarms because you can strip your notification a little bit request specific. For example, not everything, like you can skip health checks, for example. It will be easy to do. And you can really focus and trigger your alarms on really business important things and requests. But my service mesh has it. Also true statement. Some service meshes, like Istio, offers you tracing out of the box. But it's not deep enough in my point. It might work, but if you want to go deep, you need to add additional instrumentation. What I mean by that? Istio actually only tracking the requests which come in between your services or in or out from your service mesh. If you're using some K-value database locally to store something, you will not see anything in those traces. And if you're using, for example, slow hard drive for some reason, you might see some performance issues. And you will not be able to debug them through the tracing without some additional instrumentation for your application. So yes, service meshes does it. And if you're okay to using it, please do it. My cloud provider do it for me for free. Also true. Some cloud providers offering traces. For example, Google Cloud Stackdriver Trace and AWS X-Ray. If you're using cloud provider, integration with their solutions almost seamless and super easy. But don't forget, if you look in the whole Kubernetes ecosystem, right now everyone, or most of the companies trying to use not one cloud, multi-clouds. Also don't forget about on-prem or hybrid clouds. And if you married to one cloud provider, you probably will not be satisfied, which will require you to use some other solutions. But if you're using only one cloud provider and you can use whatever they provide, that's perfect. Final thoughts. We saw tracing, how it works, what it does, how it helps. But don't forget, nothing comes for free in this life. If you're adding something, it first requires time. Also, tracing uses a little bit more network bandwidth, not much, but some. Also, because it's some additional CPU cycles. It's also, if you're really short on the CPU, it might affect performance, but slightly. So be cautious and think about time and effort and if you actually need it or not. But I highly encourage you to try tracing. It's a really interesting thing. At this point, we're ready for questions.
I have one question. So I'm using the OpenTracing using Jaeger. So sometimes I do the formatting. So I send thousands of HTTP requests to the Jaeger and I want to find out the exact request, which some of them are failed, right? I want to find one specific request. So, but I cannot find it because it lists thousands of requests there. So my question is, how can I get this exact request?
Okay, the question was, I can repeat. The question was what I'm supposed to do if I'm sending thousands of requests to the Jaeger, how I'm doing search. Let me show you the UI, and I can answer that one. I hope our demo app will help us. Give me 1 second. Pretty much in Jaeger, you can search not only the duration on the request, you can search on the, oh, come on. Demo gods, be with me. Here we go. As you can see, you can search for the tag, something like HTTP exit code. So for example, if you know that you're trying to find traces which failed, you're probably not returning something like 200 code. You're returning 500, which means if you're looking for only those specific traces, you will see your failures. Also, if you structure traces properly, you have many tags on them, and you can search by the tags.
I mean, actually, most of them are 200, but I want to find a specific.
Yeah, you can use on the C and the tags, you can use HTTP dot.
URL. Can I use the URL?
For the
request
search?
the URL. I can put a time step in my URL. And
yes.
Yes. Okay.
Jaeger allows you to search by, as Ashlie pointed, yes, by URL.
Okay, I put the time step to the tags and search.
Yeah.
Right. Thank you.
Yes, you can do it. Like, still that one, then that. So 1, 2, 3, 4.
Thanks. Great talk. You said it never comes for free. Can you give us a bit more word about benchmark result, like how much overhead adds to it? And also, does it support conditional tracing? For example, if my end-to-end request timeout, like 10% of my request timeout, then I like toggle the tracing on and something like that.
Do you want to take this one?
So we didn't do too many benchmarks because we were just trying to get tracing running on our system for our testing purposes. So right now it's kind of in our test cluster, but it's not deployed with any of the services that we give to customers. As far as conditional tracing, there are ways that you can write your own version of how to turn on tracing. So we've been tracing basically everything that goes through our system. You can have a probabilistic tracer, so it will only trace a percentage of the requests that pass through the system. There is also a way to create your own function that determines which requests should be traced. So if you were to implement one of those functions, you could perhaps monitor your system and say, oh, I see things are failing, please turn on tracing for me.
Okay, I have a question that say I have a giant applications that is writing in different programming languages. The service is writing in Go and the service B is writing in C++. Can we still use OpenTracing here, or is there any best practice to handle this kind of situation in your aspects?
It depends how you're using it. For example, OpenTracing SDK, they do have libraries for Go, C++, Java, C#, so JavaScript,
so
whatever.
We can mix them up to...
Oh yeah. At the end, you're getting everything into the same system, into the Jaeger, and UI will be the same, but traces will look the same. And yes, you can send them from the different languages.
Okay, thank you.
Sure. That's the gentleman over there.
So here you show the example how to tracing the HTTP. So I'm thinking that is it possible that we can trace the message into the messaging queue, such as the RabbitMQ queue? There is some message in our system that you will come into the messaging queue and then out, and then go out the messaging queue. Is it possible then connect the incoming message in the messaging queue and outgoing?
So you want to trace the amount of time that it's in the messaging queue? Is that what you're after?
Yeah. We have the message broker. So I would like to trace the messaging and connect the applications which subscribe to the message broker or produce the message to the broker.
Yes. So if you keep some sort of context object around with the data that is actually inside of the queue, you should be able to begin a trace when you place the object in the message queue, and then perhaps once you pull it out of the message queue, you can end the trace. So it's more of figuring out a way to do it nice and easily with the existing code and finding the right places to begin and end your traces. Because really what you need from OpenTracing to actually begin and end a span or begin and end a trace is this top line, which starts the trace, and this second line, which finishes the trace. So as long as you have those two calls somewhere in your code, you will collect a trace. The key is finding the right places to put those two lines. Does that kind of make sense?
Means that I need to start tracing in the producer and then something like finish the tracing in the consumer.
Yes, that would be correct.
Okay.
So sorry, a little bit addition. So pretty much if you can add trace ID from the content into your consumer and producer and exchange it between them, some additional tag for the message, it will automatically be populated. Because the distributing tracing works on, trace has ID and the span has trace IDs, and then it automatically collects everything and combines them together. And that's gentleman over there, I believe.
Ronald, what's your experience on aggregating traces with logins without jumping through systems?
Sorry, what?
I'm wondering what's your experience on aggregating logins and traces without jumping through all the systems? Connecting the traces and logins.
That's yours.
So we mostly, I believe, use traces kind of as an overview of the system. So traces kind of give you parts of the information that you can use to look up specific log messages. Perhaps, say you have FluentD or some other logging service which you can insert tags into the logs as well. So you could use the tracing system to find the request that is causing trouble in the system, like say your failed request or your request that timed out. And you can look at the tags inside of that request, and based on the tags, if you have like a request ID or something that you've inserted in there, you can use that tag to kind of look up specific log messages. So you use them in combination, but one or the other is not necessarily all you need to solve your problem.
Also, I can a little bit more. If you able to use Google Cloud Provider, they not only introduced tracing, they actually introduced really cool features like logs to traces to source code if you hold source code on them, and they do it automatically. It's super cool, but unfortunately I only saw it in Google Cloud. I don't know if it works for you or not.
My feeling is, trace is important and log is important, but it seems if I would like my system is microservice based, then it really need a lot of extra code to enable this function to make it work. Then it means a lot of workload because all the costs. Is there any plan in the future, for example, to make it simple, like combination or works with the message bus or with the log to correlate it, so let's make the code change as less as possible. In the past?
Sure, you pretty much want to add tracing as easy as possible. What we were doing, I don't know your specifically your application. For our case, it was a little bit easy. We were using code generators, and pretty much for us, we just added tracing in one code, in one template, and that's it. It was applied everywhere. Once we generated code, that's it.
Yeah. The other thing is you can look for high impact areas. For instance, we traced incoming and outgoing requests, which actually gives you fairly good insights into some parts of the system. And so based off of that, you can figure out where you want to add tracing next. So the important thing to realize is that you don't have to trace the entire application to get data out of it. You can trace just specific parts of it, figure out which parts you want to know more information about, and then figure out good ways to add tracing to just those little parts.
There's no magic pill, unfortunately. Okay. It all depends on your use case.
Yeah, thank you.
Hey. Thank you so much, everyone. Sorry, but we're out of time already. I'm sorry. We can talk after if you want to. Thank you.